Welcome to our today's mathematics lesson, and today we are going to look at connecting percentages with fractions and decimals. Earlier on in our previous lessons, we have looked at fractions, we have looked at decimals, and we realized that both fractions and decimals form part of a whole. They usually form part of a whole, which means that when we start connecting decimals and fractions as we relate to percentages, you'll find that all the three relate to each other. So it is very necessary that we have the idea of how to work out this. Now, closely when we look at it, you find that percentages are very closely related to fractions. This percent is simply a fraction whose denominator is 100. A percentage is simply a fraction whose denominator is 100. Now, the word percent, this word is a Latin word which means out of, out of 100. So when we say percent, we are only trying to say out of 100. When we look at currencies, for example, we have a dollar, and we say $1 is equivalent to 100 cents. $1 is equivalent to 100 cents. When we talk about a century, is equivalent to 100 years. So usually in our daily lives and daily situations, you will find that percentages are mostly used. When we look at things like interest rates, discounts, test results, and statistics, so percentages are used in many everyday situations, and interest rates, discounts, test results, and statistics are usually described using percentages. They are usually described using percentages. Why this is so? It is because when it is easier to compare two different results using percentages other than when you use either decimals or fractions. Now, I want us to take an example of an experiment done by a netball player in a netball pitch. Now, in netball, we can give a girl a total of 40 attempts. So she has 40 attempts to try and shoot and score, but successful ones are 30. So which means if we want to find out the accuracy of this girl, she simply scored 30 goals out of the total number of attempts she was given, which was 40. Let us also look at another girl who was given total attempts as 25, and she managed to successfully score 19 goals. So you'll find that her accuracy is 19 over 25. 19 over 25. So when we say we want to compare the first girl here and the second girl here and find out who was more accurate. You see, this is 30 over 40. This is 19 over 25. It looks a bit odd. We cannot easily find the results. And that's why we now say, when we bring in the percentage, it becomes very easy to compare the results. Let us bring in the percentages for the first girl as well as the second girl. So when you simplify this fraction, it is 3 over 4. Then we want to have an equivalent fraction of 3 over 4, but the denominator should be 100. So multiply the denominator by 25, multiply the numerator by 25. You'll get that what you have here is 75 over 100. That is what we have, which is the same as 75%. For this other girl, to get equivalent, you shall multiply here by 4, multiply the numerator also by 4, so that we have the denominator as 100, and the numerator there, we are going to have 76, which is simply 76%. What you notice is this. The first girl scored a total of 30 goals. Too many goals out of the 40. The second girl only scored 19 out of 25. However, when it comes to accuracy, the second girl who scored 19 out of 25 has got a higher percentage of accuracy, that is 76%, unlike the one who scored 30 out of 40 who was 75%. So when you express a fraction as a percentage, it is very, very easy for a student to compare two results. That is how important percentages work. So let us now go in details and understand what percentage is and how it is applied. Percentages have been used for hundreds of years, but the symbol we use today is fairly recent. What we are saying, the word was there. When you say percent, it was there long time ago. But there is a symbol that we use currently, which is too recent. This symbol is this. That symbol means, the symbol we have here means percent. Percent comes from a Latin word which says percentum. It comes from a Latin word, percentum. This one is a Latin word, percentum, which means out of 100. It means out of 100. So the symbol we are going to use is like this. It means percent. This percent came from a Latin word which says percentum, which stands for out of 100. For example, we can say 35%. 35%. This 35% means 35 out of 100. It means 35 out of 100, or 35 over 100. Or we can also say 0.35. So all this we are just expressing the same value. That 5% is equivalent to saying 35 out of 100, or 35 over 100, or 0.35. Remember, this is equivalent to 35 hundredths. Now, these percentages we are talking about, remember the symbol for percentage. I'll put it there. This symbol that we are going to use should remain on. Now, these percentages are very useful. The percentages are a useful way of comparing fractions. Useful ways of comparing fractions are percentages. I want us to see this. For example, we have a fraction. Take, for example, 3 over 4 and 18 over 25. Now, these are two different fractions. We want to compare them. 3 over 4 and 18 over 25. I've said the easiest way is when we express the two as percentages, then it becomes very, very easy for us to express this. So the first part here, 3 over 4, it can be written as an equivalent fraction, which will mean this is 75 over 100. 75 over 100. You realize that we have multiplied this one by 3. We have multiplied this one by 25 and 4 also by 25 to get the equivalent fraction, which is 75 over 100. And as earlier said, 75 over 100 is the same as 75%. The same as 75%. So we are done with the first fraction. The second fraction here, we want an equivalent fraction of 18 over 25. So 18 over 25, you'll find that this fraction is simply the same as 72 over 100. What has happened for us to attain the equivalent fraction? We have multiplied 25 by 4 to get 100, multiply 18 by 4 to get 72. And at the moment we have 72 over 100, then it implies this is equivalent to 72%. So when you look at the two fractions, we have been able to change 3 over 4 as a percentage, which is the same as 75%, while 18 over 25 is 72%. In simple terms, we can see that 75% is greater than 72%. Therefore, 75% stood for 3 over 4. We can say 3 over 4 is greater than 18 over 25. What have we proved here? We have simply shown that we can compare fraction using percentages. It is also important to understand the relationship and the connection between fractions, decimals, and percentages. It is important to understand the relationship between fractions, decimals, and percentages. It is very, very important for us to understand this. Now, this can be displayed on a fraction wall diagram, as we are going to see. A fraction wall diagram. The issue of understanding the relationship can be displayed using a fraction wall diagram. Now, in a fraction wall diagram, we have, it's a diagram giving us the measurements. So the whole of this line is simply 100 meters, 100 centimeters, sorry. It's 1 meter, which is equivalent to 100 centimeters. We are going to divide it into smaller units, and the smaller units will mean I want this line to be divided into 10 parts, where the 10 parts here are going to represent the smaller units of this particular ruler. Now, having said this, you'll notice that this here, this is a scale. In a scale, we have 0 here as our 0%. So I want us to represent percentages first. And when we represent percentages here, it is ranging from 0%. The last one is 100%, which means the first one is 10%, 20%, 30%, 40%, 50%, 60%, 70%, 80%, 90%, and 100%. The next one is decimal. It's simple. For a decimal, we are still maintaining. At the point where we have, I want us to take the initial part remains. It still stands for, all this is just for a 0. So this, what we have initially is for our percentages. Let us look at decimal. What does it say about the decimals? For decimal, this one remains a 0. 10% is a 0.1. 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9, and 10, which is, 1.0. Now, already we have showed the diagram. The fraction diagram is showing us the relationship between the percentages and the decimals. So if I ask you to convert 70% into decimal, you'll just look at 70 and say this is equivalent to 0.7 as a decimal. If you want 30 into decimal, it is 0.3. If you want 0.9 into percentage, it is 90%. Then we have, this one represents the decimal. We have another wall to represent a whole. That is one complete. One whole. Now, when we talk about one whole, this is the situation. There is no division, there is no fragmentation, there are no scales, but we are saying from the beginning to the end represents one whole, which means 1 is equivalent to 1.0. 1 is equivalent to 100%. If we have halves, then we can also represent halves. Now we have halves there. What you'll notice from this is that it is made up of two halves. So this one is 1/2. If I may shade, I'll show it by this. So that is 1/2. 2. So this is 1/2, and this is another half. So how many halves makes 100%? 2. How many halves makes 1.0? 2. How many halves makes a whole? Those are 2 halves. We have a wall that will shows when we have thirds. So we have that representing thirds, and for thirds, you find that it is divided into 3 thirds. So what you notice is that this first third is a third. So 3 of these makes a whole, or 100%. And we can have the last one for quarters. So the portion I've shown there represents a quarter, 1/4. 1/4. Now, what are we trying to say? From the fraction wall, it is very easy for you to identify what you need. For example, a quarter is equivalent to 25%, or is simply equivalent to 0.25, because we have not reached 3, we have not below 2, or just 25%. Or if it's somewhere here, a quarter would give us something a half, which is 1/4. So what are we trying to say here? A fraction wall diagram summarizes or simplifies the conversion of fraction into decimal or the percentages, as we have seen. I want you to continue and see, according to the scale, and see how to come up with other fraction wall for the following. For fifths, for sixths, so come up with other drawing fraction wall to represent fifths, sixths, eighths, ninths, and tenths. And then we shall look at it. So to continue, I want also to say that besides the fraction wall diagram that display information for easier conversion, it is also important to memorize. It is also important to memorize the most commonly used conversions. It's also important for us to memorize the most commonly used conversions. This can be, we shall take a few of the explanation. Now, this can be shown as follows. Let us look at a few. We have words diagram, fraction, decimal, percentage, words diagram, fraction, decimal, percentage. So this, we shall look at a few. It is also a diagram that shows us the most commonly used conversions. Take, for example, if you want to represent a whole, in the diagram, I want us to have units of 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Then 1, have 2, we have 10 boxes. 1, 2, 3, 4, 5, 6, 7, 8, 9. Now, what we have is simply a whole, assuming that all these boxes are selected. All these boxes are selected such that we have highlighted everything here. So you'll find that what we have are a total of how many units? 10 by 10. 10 by 10 is a total of 100 units, so this is 100%. As a decimal, what we have, it is simply 1 decimal and 1 fraction. So this is if everything was required. What if what we required was a half? For 1/2, we shall require to share the first 5. So I've got 5 columns shaded, and I've got 5 columns unshaded. This, as a fraction, is called 1/2, and as a decimal is called 0.5, and as a percentage, it is called 50%. So by just looking at what we have, we can simply convert. If we required to represent a quarter, then it would mean that out of 100 boxes here, only 25 are shaded. So these ones will be removed. That is 10. We need 25. And then 5 more. So we have 5 shaded, 25 boxes shaded out of 100 boxes, which means that what we have here is 25 over 100, which is a quarter. And as a fraction, it is simple. As a decimal, it is 0.25. And as a percentage, it is 25%. This diagram is simply for showing the conversion of most commonly used conversions. I want you at your own time to also be able to prepare a diagram for the following. For 1/5, for 1/10, and for 1/100. Prepare those 3. Another very important fact about decimals is we want to say that the number fact in the table used can also do other conversions. From the table that we've just seen, we find that the number fact in that table that we have used can be used to do other conversion. In the table, and here we are referring to the just finished table, can be used to do other conversions. What we want to say is this. You realize that our total number of boxes in the table that we just did, the diagram had 10 boxes for the rows and 10 for the columns, which means that 10 by 10 is equivalent to 100. So the small boxes were 100. So if somebody asks you to convert 1/4, simple. From the table, we realize that 1/4 is simply the same as 0.25, which is 25%. Then, if we were to look for something different, for example, Supposing we multiply this one by 3, so that we shall have 3 over 4, or multiply this one by 9, so that you can have 9 over 4, then you'll find that it's not difficult. We can simply get what we require. Why are we saying that? For if we multiply a quarter by 3 is 3 over 4. In decimal, it will be 3 multiplied by 0.25, which will be 0.75, which is the same as 3 again times 75, which is 75%. Note that we have arrived at 75% right from the first representation of a quarter. For this other side, when you use this path, we want to find out what percentage is 9 over 4. Then we simply work out. Do we multiply by 9? So 1 times 9 is 9, and 4 times 1 over 4 times 9 is 9 over 4. Then it will mean that when you want to change into this, you'll multiply this one here by 9. And when you multiply by 9, you'll find that you are getting 2.25, which is the same as 225%. So we have been able to convert, using just 1 over 4, we have been able to find 9 over 4 in terms of percentage. How did we do that? I'll get you back. Let us see. If we were asked for 5 over 4, then it will mean that this one was multiplied by 5. So a quarter multiplied by 5 is 5 over 4, which implies in decimal it is 0.25 multiplied by 5, which is 1.25. Or in percentage, it is multiplied by 100, which is 125%. So you can use the first fraction to simply get the others. You can still look at one more on the same here. Given that that 1 over 5 is equals to 20%. Complete the following. Complete the following. Now, we want to complete the following. 3 over 5 is equals to what percentage? And B, 6 over 5 is equals to what percentage? Simple. We have been given 1 over 5 is 20%. How about 3 over 5? You realize that for us to get a 3 over 5, then a fifth must have been multiplied by something. And what is that something? Take 3, the denominator divide by 1, you find it is 3. So they have simply multiplied 3. They have simply multiplied this one by 3 to get this. Therefore, to get what is here, we shall take the solution as 20% times 3, which gives us 60%. What happened? If we multiplied a fifth by 3 to get 3 over 5, then we also multiply 20% by 3 to get what you are calling 60%. For the second part here, we have 6 over 5. How did we get 6 and yet given that we have 1 over 5? If we multiplied by 6. If we multiplied by 6, a fifth by 6 to get 6 over 5, then it means here we shall have 20 multiplied by 6%, which is 120%. percent, 120%. So that is it for now. When we come back, we shall continue looking at more exercises that touches on percentages, decimals, and fractions. Thank you.